Okay, been a few days. Rob has been working on this rusty door pillar. He's got it repaired, areas patched up. He had the door hung a little while ago, fits properly, seems to adjust nicely. You shot paint up in here already?
Yeah.
Everything's painted up inside. Door fits. I'm sure we shot this rail, but the rail is welded in. Cross member support is welded in. He has a cover here. You can go ahead and set it kind of where it goes. It's actually a door pillar reinforcement. It was pretty much rotted away. So he's got one made that's going to get put in here and tacked in place. He's ready to put it in, so I can get some shots here before that gets done. I'm going to go check on the rear door hinges. Can you go ahead and fix that hole below the striker? Or do you need to fit the door first?
Yeah, well, I should fit the door.
Because that might have collapsed slightly or something?
Yeah, it's
squished a little bit?
Squished.
It's hard to say.
So I got to pull it out. I brought the slide hammer in. So.
All right. So we'll get this tacked in, get the door hung. I'm going to check on the hinges. The aluminum hinges for the doors, 2 of them were broken, and I'm having those welded up and repaired. 3 of them were broken? So we're having them. I only got 2 across the street. He's going to get this put in, probably rehang the door. We'll get the rear door set in place. We're going to kind of work down this side of the car first. We're in the process of accumulating goodies. We probably didn't shoot this before, but the coupler came in. This is what the flywheel will mount to. We've already screwed it onto here just with our fingers, tightening these bolts. If you tighten 3 bolts with just your fingers, you can no longer pull it off of there. It squeezes that tight. And then we've got this expensive little shaft here that just so happens to fit absolutely flawlessly inside, except the very center of the shaft going through the armature has about 2/1000ths of an area that they did not reach when they machined that out. So this shaft hits it and stops. So it stops kind of in the middle, goes in that far. We're not sure we even need a shaft on this end. We probably don't. So we're going to cut this down and fit it on the other side. And it'll go in about the same distance. But it fits so tight with no play that we'll slide the shaft in the other side and then weld around it. Because we need to extend out the back about 3 to 4 inches in order to attach a pulley and so on there. We haven't decided yet whether we're going to cut a keyway in this or whether we're going to get another clamp similar to this to hold our things together. We're in the process of getting the aluminum in for the adapter plate and ordering the aluminum for the flywheel. And that'll be coming this week, maybe even by Friday we'll have that in. We'll get some shots of that when we get ready to make the flywheel and the adapter. We got our aluminum plate in, but because we don't want to ruin the aluminum plate, I bought a piece of MDF, and we're going to build an adapter out of this MDF. Instead of aluminum, we're actually going to drill it, we're actually going to tap it, we're going to shape the center, fit it on, take measurements, see how the flywheel is going to fit properly, because we've not made the flywheel yet. The aluminum for that should be in today. We've drilled the holes that are going to be tapped. Now he's going to drill the 10mm through holes that are going to go clean through the adapter into the motor, because the motor actually is tapped, but the valve housing on the transmission is not. So the adapter has to have the threads for the bell housing, and it has to have through holes on it for the motor. So we're in the process of doing that. When he gets these done, we'll cut the center out, and then we'll take it back and test fit it. We'll tap the holes and then we'll test fit it. We're going to cut the center out like we would if this was an aluminum plate. Pardon the noise. Work must continue. The guys are working on some parts for a Mercedes here. How far through are you? Shot here when he gets done. It's going to be about 5 minutes.
I don't care on a little test piece.
We got the hole cut out. I tapped a couple of holes so far in the MDF. These are through holes that will allow bolts to come through. These are tapped holes that will allow us to mount the bell housing to here. We're going to finish tapping these holes. We're going to leave it big like this. I don't think it's going to interfere with anything right now. We won't trim it around the outside at this point. Get the rest of these holes tapped and get this thing tested out, make sure it works. We've got our MDF drilled and tapped, cut out. Again, the perimeter is not trimmed, but sets right on the transmission perfectly. The dowel holes are aligned. We had to ream them slightly because they were too tight. We didn't have quite the right size drill bit. We're going to flip it upside down now and check how centered the threaded holes are to the transmission. We already had it mounted on the motor. Fits perfectly. We even had bolts into it. So we're going to flip it over and see what it looks like. I think I'm going to flip it right over. Is that motor stable where it is?
Yeah, it's not going to go anywhere.
All right, let me flip this right over onto the motor, and you can actually bolt through this into your motor, and we can check the alignment of these other holes.
Yeah.
We have our adapter on. This MDF is 1/2 inch. This aluminum plate we're going to end up using is 5/8. Boy, it mounts right up here and fits perfectly. We don't have long enough bolts, not enough bolts here in the 10 millimeter to go through properly into the motor. I'm sorry, into the MDF. So we had to put a clamp at the top there, but it's on our dowel pins. It's lined up. We're going to get a flashlight, look down through the through shaft of the motor and make sure that the input shaft is dead in the middle. We got to do some measuring. The flywheel high tensile aluminum block for us cutting the flywheel will be in today, I think. And then I don't know that we're going to attempt that here ourselves. Well, we'll get shots after we get this, probably get our aluminum cut out. The flywheel is going to have to be made with a bore at the back to take the bearing that this input shaft goes into. So the flywheel will have, like I said, a cutout for that. But it fits properly, lines right up, and it looks like we're going to be able to mate that motor directly up to this transmission. It'll actually be done to the transmission that's in the car over here, but this is a duplicate transmission, so we're using it for testing purposes. We'll get shots after we get our aluminum cut, get our flywheel blank in, get a flywheel manufactured, And then we'll be able to assemble this and set it in the car and do some other measurements for the gasoline motor. Now we're trying the aluminum plate, obviously. Play it, you keep it that speed. I'm going to change the RPMs here a little bit. You're getting good chips, right?
Yeah, chips are nice.
Other than the fact I don't like the squeal. What's your RPMs up to now?
750.
All right, let's leave it there. I think we're going to be okay. We're cutting the hole out of the center. They've already drilled all the outside holes, including the pilot holes. Get a shot of this when it gets towards the end because the nice music it's producing. It's going to take about 5 minutes or so if we don't break this cutter to get all the way around. Okay, it's been probably 5 or 10 minutes. This is a very expensive, called a high helix cutter, about $100 for that cutter, 90 I think, and it might have been more, but anyway, we've had it a number of years. It's made for cutting aluminum.
It wants to fall, let it fall.
Gonna let it kind of finish and overpass the section.
Yeah.
Okay. Got our hole, kind of a pilot hole that helps us pilot this onto the on the electric motor itself, because it has a little ring in there that this will drop onto. As long as this is setting in here, we're gonna reset up. And I think I'm gonna slide these in like my son suggested on the inner, and he's gonna go get a profile cut. I'll leave that same cutter in because that's what we'll use. And then we'll take that high helix cutter and we'll go around this perimeter and we'll shape this properly to the shape it's supposed to be. And we'll have this thing all done and we'll go in and see if we screwed it up or whether this thing's going to work. We got holes to tap too, correct?
Yes.
Okay. So let's, I'll get this readjusted one at a time, correct? Because you do not want this to move.
Yeah, do it.
All right,
Just take
we'll get some
one off.
shots if we get the profile cut. And we did get, you want to hold this thing up?
This?
Yeah. We did get our 7075 high tensile aluminum for our flywheel. This piece of aluminum here is $60 per inch. There's about 3.25 inches here. So that block of aluminum was about $180, maybe $200 shipped. We just got it in. This will be carving our flywheel out of with a pilot hole here for a bearing to slide into for the input shaft of the transmission to locate. And we'll get shots after we get the profile of this beast up here cut. We have our hole in the center, all the holes bored. We're pretty confident that this is correct, so it's kind of too late to do anything about it anyway, so we're going to go ahead and cut the perimeter shape. So this is ready to install. We have not drawn up a program at this point for the flywheel. Work on that next week. Friday afternoon, 1 o'clock. I don't know how far we'll get with a flywheel program or whether my son would like it optically scanned and then modified or whether he just wants to draw something up. So we're going to look into that this afternoon. Get a shot of this when it's all completed.
Lasts for several days.
All right, the adapter is done. We've even drilled through here for the motor mount brackets. The CMM company that we hired to profile pick up all the holes in our transmission bell housing and our motor. Forgot these two. Isn't a big deal. We will come back here, mount it up, scribe through here, and bolt them on. But the adapter plate works. It fits here perfectly. Everything lines up. This is bolted on. We're going to lay it down, and Colin's going to take a peek at the other side. Make sure that the input shaft to the transmission is dead in the middle. You want me to tip that up a little bit?
Well, it looks in the middle.
You want me to tip it up? Can you get this camera in there by chance? With enough light?
I don't know what we can.
You can push that.
Shove it, pick it up. Push this right under
Yeah, we
there.
pushed that hammer under there before.
The hammer underneath.
All right.
All right, let me over there where he's at. Can you see in there well enough?
You can see in there.
If I put the camera here, can you see through that enough to still get a battery or a lens in there? The flashlight, I mean. Can I see back in there well enough or not?
You're not seeing it yet.
Okay, hang on.
Oh, yeah,
There.
right there.
Can you see it in the lens there? Good enough or not?
Yeah.
Dead in the middle, isn't it?
I'm not sure. To me, it doesn't seem that way this time.
I'm looking at it here through the camera. Looks like I can see the gear for the transmission gear all the way around. I'm going to shut the camera off and take a peek just
All right.
manually here.
It's not gonna make a difference if I spin anything.
Okay, we've got our aluminum in. I showed that to you before. I cut a pocket. I trued it up, faced it, cut a pocket in it. We had to swap. Oh, you already switched it back? Where's the other one? Back on the floor?
Yep, we want to see it.
The one on the floor back here we had to put on, which will reach out and grab something 12 inches or so in diameter.
That's good.
Now we're going back to this one. Grab that flywheel and see if you can pocket that on there. Now this will go on. Hold it against there while someone tightens it. As soon as you snug that,
Other way. Other way.
other way.
It's going out.
That makes it smaller. You're used to it the other way because
Other way.
other way.
There you go.
You're used to it the other way because we're coming down on stuff before. Now you're opening it inside of a hole. Touch that, all of them. Every one of them. About the same. And then I want you to reef on them pretty good when you're done. I got a lot of cutting to do. I don't want it moving.
It ain't gonna move.
Get it good and tight.
We got it. Should
Each one.
Should check it to make sure that it's
Okay? Then we'll fire it up and we'll check it to see how true it is and all that.
Slick.
You're good enough. You're good enough. You're doing a Richard on it. That's good enough for me. How's it look?
it's a little bit of wobble, I'd say.
Huh?
I'd say there's a little bit of wobble.
I'll be refacing it. You held it against those jaws when you tightened it?
Oh yeah. I mean, there's barely any.
I'll be refacing it anyway.
There's some.
It's all going to be cutting off. That's okay. We'll, if we have to true up a few thousandths on each side, then I'm all right with that. Anyway, I spent a number of hours drawing up and designing this flywheel based on the old flywheel. This is what we came up with. This is kind of what, nope, not while I'm, this is kind of what a 3D rendering of it's going to look like. These are my original drawings. This is half scale. We're going to put something different than the factory did. The factory put a lip all the way around this top to kind of center the pressure plate. We're going to put dowels in here. And the top of this dowel has approximately a 1/4 inch hole in it. The pressure plate has a 240 thousandths hole, so we just have to ream them slightly, and these dowels will center that pressure plate perfectly over the top. The pressure item of the pressure plate will be down here at the bottom against the disc. These are our bolt holes, our dowel holes, our vent holes. We have vent holes to the outside, just like the original flywheel. This is being machined 153 thousandths down deeper, and we're going to be screwing a steel reinforcing plate here for the surface of the clutch surface, so we don't mar up the aluminum. And then this is my dimensional sketch that I'll be using right now. So you can see with all the aluminum around here, me cutting that pocket out and truing up the surface outside and inside. Gonna fire it up, get some shots later. I've got some contouring and another company with a CNC or a digital readout mill. This mill here is an Army surplus from the Second World War, and I don't trust it for the dimensional inside. The outside shapes I'll be cutting now are not as important as the internal ones. So I'm going to do the outside, have another company across the street with a little better lathe. He's going to do the inside for me. A company quoted me $1,500 to do this, and so being capable of doing it ourselves, we decided just to go ahead with it and do it. We're developing a little bit of aluminum shavings. They're actually coming off nice and hot. I'm about 135 thousandths down. I need to go 200 thousandths down. We'll get a shot here. We have to do it manually. Not quite as messy when I come back the other way. Nice little spirals. I'll shut it down here and take a measurement of it next. Okay, flywheel, the preliminary cuts are done. We got a surface. He's going to set this in there, make sure that we have clearance once he lays it on that shaft.
You do, but you wouldn't want your fingers in there.
Well, I didn't cut.
Try that.
I didn't cut this 80 thousandths. Okay. I cut it 80 thousandths shy from what you had programmed, because you're cutting this 153 thousandths deeper for that metal insert, and I picked you back up 80 here. Now, if you want, you're pretty close, but you're not hitting. What do you got under here, gap-wise? You're not centered, but that's okay.
Yeah, I was trying to get it closer to the center, but it isn't.
Okay, but what do we have gap-wise?
A 16th.
You're under an eighth. You're under an eighth. Yeah, but do you need more? You don't really need more, right?
It should. It's going to be hard bolted.
It's going to prevent.
Go anywhere else.
It's going to prevent debris from easily getting in. Okay, it's going to be hard bolted. You need that extra material because you're carving another 153 thousandths here for that metal insert.
Yeah.
So I gave you 80 back. Okay, if you don't feel comfortable with it, I can take another 20, but I'm looking at 60, 70 thousandths there, I think. So
as long as it can rotate like this and it doesn't touch the adapter plate.
It's not touching anything. And you're not rubbing inside either.
Yeah, you don't hear any rubbing, so obviously it's cut out enough.
You know, I trued this up. It's perfectly round now.
If you were too critical on the inside dimensions, you'd hear it rub when it
Yeah, you're a little bit off eccentric-wise, so we're definitely big enough where we're not going to rub.
Obviously, you're not hitting.
All right, I'm going to run this across the street with this pilot bearing, and then he said he's going to get started this afternoon, and then maybe tomorrow you can do the programming tonight. Maybe tomorrow you can cut your holes. McMaster car is pretty fast. You might even have your components tomorrow for the The other.
Probably.
Okay, and then I'll take this shaft, chuck it up in the lathe when we get things assembled. On the other side, we got to make a determination how the motor is going to hook up, and then we'll cut this shaft down. We'll drive this shaft in. We'll cut that shaft down to 3/4 so it'll fit the next coupling. We'll get shots of that when they come in.
Yep.
We're across the street at a more precision lathe that has digital readout. Things will be able to be done a lot more precise with what he has. Now he's cleaned up the back of this so that it'll fit his machine. The jaws here hit this ledge that I left as big as I could, so he had to take about an eighth of an inch or so off of that. That allows him to grip this, and he's trued it up so that it works on his machine properly and everything's nice and flat. And he's going to start cutting these other dimensions that we talked about yesterday out of here. My son is doing a CAD. He has the CAD drawings done. He's going to do a CAD program that's going to come in and put the holes. Now, today we got the pilot here in. This will be sunk into here, buried in so that this flange is flush, and then it will pilot through these holes right here so that this thing will be perfectly centered. So he's about to start cutting and have nice hot aluminum chips flying down his shirt, things like that. So we'll get shots after we get a little farther along. This cut's about 90% done, width-wise. Depth, we're at about 1 inch. We need to go about 1.5, 1.7, somewhere in that area. The aluminum is getting pretty warm, so they're taking a break. Going to let this cool off, because the hotter this gets, the more it can warp or change while he's cutting it. He doesn't want that to happen. We'll get some shots later. He's going to put another couple hours into cutting this, and I'll get some more photos. Okay, we ordered this clutch face disc yesterday from Summit Racing. Came in today. Pretty darn fast. Came with the screws to mount it. He's not quite all the way there. This is going to set down inside of here when this is cut a little farther. Bored this through hole so that his cutter doesn't have to go to center and chatter every time it swings in. He's going to be cutting this a little deeper, cutting it a little bit wider, so this can be mounted down in the bottom and make up the difference. When this is put back in, we'll have the correct depth from here to the face of this, and then the clutch will rub on this face. So we'll get some shots when he gets this cut out a little farther.